Hello, welcome to Z Talk. This session, I'd like to talk about a new performance testing solution called K6 that I've been POC recently. I've been looking for alternative solutions for performance testing to replace JMeter, or actually more precisely, to have a second option for different scenarios. All right. So I've tested with some popular tools in the market like Locust, Siege, and K6, of course. And I have some thoughts after comparing these tools that I'd like to share with you. All right. I guess the first question you may ask is, what is K6? K6 is an open source load testing tool written by Go and developed by Grafana. It's free, developer-centric, and extensible. I guess your follow-up question is, all right, so why do you want to use it to replace JMeter then? The main reason is that JMeter does not have a CLI. I've tried some third-party solutions, actually like Taurus, to solve JMeter test execution problem, but I'm not a big fan of it. I just want a modern native CLI tool with developer-friendly APIs, lightweight, and low dependencies to integrate with CI/CD pipelines. That's basically why K6 comes to my picture. And one more great feature that K6 provides related to integration with CI/CD or automation, and JMeter doesn't, is checks and thresholds. I will explain more with examples in my demo shortly. All right. Here are some main use cases I can think of as of now. Firstly, of course, load testing. K6 is optimized for minimal resource consumption and designed for running high load tests. Actually, I'm planning to use K6 to take care of all my regression tests as a starter. And secondly, performance and synthetic monitoring, I guess, is part of my observability practices. With K6, we could run tests with a small amount of load to continuously validate the performance and availability of our production environments following the continuous testing practices. And lastly, as a more advanced scenario, that we could use K6 to simulate traffic as part of our chaos experiments, or at least trigger them from K6 tests. All right. Here comes a more detailed comparison between JMeter and K6. I want to take a couple of minutes here to explain so that I guess you follow my thought process and criteria to understand why I chose K6. Firstly, as we know, JMeter is GUI-driven testing tool written in Java. JMeter itself is fairly easy to install, but because it's written in Java, before you install JMeter, you need to install Java, especially if you're using Windows. I think it's a bit annoying to add environment variables needed for Java to function, and sometimes it can be confusing to determine which version of Java is the right one, right? On the other hand, K6 installs extremely quickly. It only takes a couple of seconds to run a simple install command, and that's it. It does not require like Node.js or any other dependencies, which I believe makes our life much easier when we are building the automation to CI/CD pipelines, right? And we just talked about GUI, right? So actually, the reality is many testing teams make decisions on load testing tools based on these facts first. I could understand that. Sometimes consider if you're in a situation where people haven't done load test before and need to learn a new tool, a GUI-driven tool like JMeter is simply the most frictionless option, I believe. A tool with a GUI will be less daunting for many testers that are used to the mostly no-code UIs like Postman, right? I have to admit here, I've always thought of JMeter as user-friendly, but if you use JMeter for the first time without any experience, consider that. Can you quickly figure out like how to create an HTTP samplers when you first start JMeter and log on the test plan screen? We have to admit that even though it's easy to catch up, but it still takes time to figure out like the differences of each controllers and samplers, how to set variables, all of those. You have to figure out how to use that GUI interface, right? So there's a learning curve out there. Well, K6 on the other hand does not have a GUI package within the tool. All is done with JavaScript with support for local and remote modules, like I pointed out earlier. So I believe it's quite developer friendly from that point of view, because you don't have take time to learn a new GUI. As long as you good at JavaScript, you're good to go, actually, right? We talk of some advantages of K6, but it's actually doesn't necessarily mean JMeter is a bad tool or is the outdated tool. Actually, for example, when we need a cost-effective way to do distributed load testing, one of JMeter's absolute best features still prevails. JMeter gives you a framework for running distributed load tests with it, which is pretty special for a free and open source tool, in my opinion. By the way, for those who are not familiar with terminology here, distributed testing means ramping up the amount of loads you are generating with your load tests, usually by increasing the number of virtual users and running multiple instances of your script on other load generators. JMeter accomplished this by designating a controller node and letting you set up worker nodes. These workers then run copies of your test plan and exert loads against your application server. A distributed execution like this takes a bit time to set up, but it does work surprisingly well on JMeter. On the other hand, K6 does not have a native distributed load testing mode. You can containerize it on your own, actually, and deploy it via Kubernetes. Also, K6 is working on a solutions for Kubernetes called K6 Operator, which makes setup significantly easier, but it's still on early stage, and I haven't tested it out yet. So as of now, I would say the more reliable solution for this scenario is to pay to use their cloud solution, and it's definitely out of scope for this demo because I'm only gonna focus on free features. All right. Lastly, before I jump to the demo, if you remember, I mentioned I had tested some other tools like Locust, right? I want to explain a bit here why I picked K6 over the other options. Locust actually seems to have picked up speed for the past couple of years, and honestly, it's getting very popular. Something special about it is it's written in Python, which is like a cute puppy of programming languages, right? So you can script using Python. I don't think there are really any other competent load testing tools that are Python based. But the problem is that Locust is maintained by the main author I believe Jonathan Heyman. There are many external contributors, but there is no commercial business during the development of Locust. It's a true community effort. I love it, but from an enterprise level solution perspective, right? It could be a risk if it's not being commercialized. That's basically the reason I didn't go with Locust. All right, demo time. This demo, I'm gonna focus on my use cases. Number one priority is to integrate K6 with Jenkins pipeline. I will show you step by step about that. Of course, you can use other CI/CD tools like GitLab CI, which is one of my favorites. I already had a series of videos about it. See the link here. Take a look if you're interested in learning more about it. The video has step-by-step instruction on how to build a pipeline using GitLab CI. So this demo, I'm going to use Jenkins. The second use case for me is to build a good presentation layer. Since I've been using Grafana as my presentation tool, integration with K6 is a no question option apparently, right? So I'm gonna show you how to integrate K6 with InfluxDB as the backend and present testing results on Grafana. Feel free to download my demo from my GitLab repo. I'm gonna publish that. To make it easy to set up and reproduce on your end, I'm gonna use Docker Compose for my demo. Right? That's basically it. Let's do it. Before I start the demo, please remember thumb up if you think it's helpful and subscribe to my channel. And more importantly, as always, please do ask question if you have anything. All right? Cool. Here is the repository for this demo. I shared the link in the description of this video, so feel free to download and play with it. All right, let's start with something simple. How about a script? Let me quickly switch to my Visual Studio Code. Under script folder, and you can see I added a simple API test as an example. As you can see at line 21, it's just a simple HTTP GET request. All right, so let's start from the beginning, from line 4 to line 14. So you're capable of specifying not only how do you want the user load to be ramped up, but also ramped down by defining stages right here. Specifically for this example, I want 5 virtual users to be created, or in other words, 5 concurrent threads or concurrent users to be ramped up gradually in a specific time frame. For example, here I defined duration is 5 seconds. All right, and then once all 5 virtual users being ramped up, I want to stay at that stage for another 10 seconds before it's ramping down. That's why I add another stage, stage 2, right here, at line 10, right? And then I'm done with my test. I want to ramp up the user from 5 to 0, right? So basically, same idea like ramp up. You can define how do you want the users to be ramped up, like right here. So you're free to define whatever patterns or the way you want the load to be generated, basically, right? Move forward, line 15. So remember, I said one of the most important features that K6 provides is check and thresholds in the beginning of this video. Specifically, thresholds. This feature is important to help you build your automation. And you're able to define thresholds based on either the metrics that come out of box with K6 or any custom metrics that you created on your own. And you can see right here at line 16, the type of the value is a list, which means you can define your thresholds with various combination of metrics, which gives you additional flexibility to define more complex SLAs. All right, and you're also able to define the scope of your threshold. In this example, it only involves one simple script, right? So the script applies globally. The threshold applies globally. But in reality, your scenarios are going to be way more complex than this one, right? It's more than likely that your use cases involve multiple scripts and modules. And in that case, you're able to define multiple thresholds and apply them accordingly by scope. If the thresholds are violated, you're going to receive a non-zero status code, which in turn means a failure of your pipeline job. All right, move forward at line 24. You see I added a check. So JMeter actually has the similar feature. As an example right here, I just added a check for HTTP status code. Same idea as threshold. If checks are failed, it's gonna fail your pipeline job. All right. So let me run case 6 real quick manually here to show you what results it's gonna return from the command line. So you got an idea how it looks. So let me, oh, by the way, K6 provides plugins with, the popular IDEs like Visual Studio Code and IntelliJ. So you can test your code directly on the IDE, all right? So back to the browser, like the plugin for Visual Studio Code right here. So you just need to install under plugin extensions right here, right? And basically there's no dependencies. All you need to do, while I'm still developing the use case or scripts on my local, all I need to do is install K6 on your laptop. So I'm using a Mac. The install is quite easy, just one simple command like brew install K6. That's it. So once it's installed, you can check by let me open the terminal, so you can check, like, let me clear my console, and you can check by typing K6 version, and here we go. It means the CLI was installed correctly and it's up and running. All right. So now all you need to do, like I said, I already installed the plugin for Visual Studio Code, so I can just run K6 from my IDE directly. So what I need to do is just open up the command palette and then issue run. Here we go. It's already pumped up K6 run current file, right? Let's try it out. Just hit enter. All right, so it's starting K6 and it's running the scripts, right? So let's give it a little bit of time and review the results. So here, basically from the default output is the command line console right here, and you can get an idea what kind what kind of matrix that comes out of box with K6. Here we go. Those are the matrix, right? And as you noticed right here, there's the check here in front of these specific metric, HTTP request duration. So basically that was the threshold and check we put in place in our scripts right here at line 24 again. So we had a HTTP status check in place here, right? That's why there is a check icon in front of the status right here. right? As you can see, the status was 200, so it passed the test. And another check with the threshold. As you can see, I added a threshold against these HTTP request duration metrics. Here we go. That's why we got a check icon right here if everything passed the threshold. And we can not, as I mentioned, the value right here is a list. So we can combine multiple metrics actually into these thresholds. Like right now, I'm only use one average metrics as the threshold. Actually, we can do more by adding, as you can see, there besides average, there's other metrics like minimum, median, max, percentile 90, percentile 95. We can include like multiple metrics into our thresholds, something like that. All right. Let me show you what if it didn't pass check or threshold. What we're gonna get basically is kind of, you can you already guessed it. So you will get a X icon before the matrix where you put in to check or thresholds. So let me manually fail these job by let's say we want a status equals to 400 instead of 200, something like that. Equals 400. In that case, let's see. Let me rerun the script by open up the command palette and issue run k6. All right, hit enter. All right, let's give it a little bit of time. This time, because we manually put a wrong status called 400, so it's gonna return it's gonna fail the check, right? So let's see, what do we got here? All right, see here? There's the X icon in front of the status check right here. We were, the script was looking for a return code, 400 return code, but actually we got a 200, right? So that's why it did not pass the check right here. Right here, and it's gonna return a non-zero status code. All right. So let me change it back to 200 and show you more integration with InfluxDB, Grafana, and Jenkins job, right? Here's my Docker Compose file. Let me show you the integration part as I promised. If you're not familiar with Docker, I had a series of videos to talk about it. Here's the link. Feel free to take a look. I believe it's going to be quite helpful to understand and set up your own Docker Compose file, right? Basically, Docker Compose helps you to package things up and set up a dev environment quickly. Like, for example, by defining at line 2, by defining networks, the Docker containers are able to communicate with each other. And actually, you are able to define more than one networks in a single Docker Compose file to segregate your networks. For scenarios like you want a specific service, let's say service A, to talk to service B only. So in that case, you can create multiple networks and include service A and service B into one network and the other into another network. In that way, service A only talks to service B, something like that. To spin up the environment, all you need to do is to run a simple Docker compose command, like here. Docker compose a space up and space -d basically means detach mode. And once you issue this command at the path where your Docker compose.yaml file is stored, Docker is going to take care of the rest. If it's the first time, it's going to download the images from the Docker repository based on the services that you define in your YAML file, and then configure each of services accordingly based on the specifications you define in the Docker compose.yaml. All right, so I've already issued that command. So once it's done, let me show you real quick by issue docker ps. And as you can see, there are 3 containers as running. So one is for Grafana, one is for Jenkins, and the other is for InfluxDB. That's exactly what I defined in my services right here. So InfluxDB, Grafana, and Jenkins, right? So one more thing to note for backend InfluxDB specifically, as we know, the latest version of InfluxDB is v2.x, right? But actually, the K6 only supports InfluxDB with version 1.x, right? It doesn't support v2 just yet. So you have to specify an older version right here, like 1.8 is going to be perfect. Otherwise, if you did not specify the tag right here, is downloaded the latest version, which is 2.1 or 2.0. So anyway, as long as it's v2, you're going to have problem because you will find out the matrix is not able to send to the to InfluxDB. All right, that's one thing you need to take note right here, right? And Grafana it supports the latest version, so you just use the latest tag. That's fine. And here I attach some volumes to store the dashboard right here. Dashboard. So like this guy, this dashboard, I did not create on my own. I just steal a great dashboard from Grafana dashboard repository. Like the README here, I mentioned the dashboard in this dashboard folder is adapted from the Grafana dashboard repository right here. And here is the ID of that dashboard. The only 2 small modification is the data source is configured to use the Docker created in the InfluxDB data source, and the time period is now to 15 minutes. That's the only 2 modifications I did for this dashboard. All right, and that's pretty much it. So Docker. Back to the my command line as Docker ps. As you can see, Grafana, there's container up and running for Grafana. So to get access to Grafana, all you need to do just switch to your browser and do localhost 3000. That's gonna be your Grafana, right? And here we go. This is the case dashboard I was talking about. So it's gonna it's automatically configured and loaded up on Grafana. So it's like come out of box once you run the Docker compose command, right? So that's pretty much the Docker compose and Grafana and InfluxDB. Next, I'm gonna show you how do you configure to integrate with Jenkins, and then how did you hook up when you create a Jenkins pipeline? How do you hook up with a GitLab repository? I will show you step by step how to do that. By the way, to be clear, let me explain a little bit more about the structure of my repository. Actually, I provided you two options to kick off K6. One is with a Jenkins pipeline automation job to kick it off. Another is by issuing another Docker Compose command I list out in these scripts right here. So that's why if we review our Docker Compose YAML file again, you see a service, a K6 service that defined right here from lines 30 to 39. Basically, that's a demo. I want to show you how did you use Docker Compose to demo integration between K6, Grafana, and InfluxDB. As you can see here in the environment, for these specific K6 service, so it's gonna spin up a K6 container, and it's gonna run the whatever scripts you created in the scripts folder. And the environment settings, as you can see here, I set to export the result of the your script to the backend, which is InfluxDB, right? And pointed to the InfluxDB URL right here. That's the benefits we define networks, so that I can use the services name directly here as the DNS, right? So Docker is gonna able to locate the containers it wants to communicate with, right? So as you can see, is InfluxDB, the port is 8086, right? And /K6, basically this K6 is a table that I pre-configured in the other services. Let's go up to the InfluxDB service that defined right here. As you can see, at line 13 and 14, I had an environment in place to as InfluxDB equal DB equal K6. Basically, what it does is to create a table called K6 if there was no table out there, right? That's basically it. Once the first step, when the table is created, the K6 table is created, whatever matrix or results gonna be feeding to that specific table K6. Right, that's basically it. Now let's jump to Jenkins. Here in the Jenkins session, this Jenkins service, as you can see, I did not do much customization. I just grabbed the official image right here without any customization because I want to show you how do I configure from the beginning once you install Jenkins. If you're familiar with this process, you can actually build a custom Jenkins image to package the configuration up so that you don't have to do it every time. Like for example, the thing I want to demo to show you how to integrate Jenkins with GitLab repository, you are gonna need to install some additional plugins like GitLab API, GitLab authentication, something like that. So you can actually build a custom image to pre-install those plugins ahead of time, so you don't have to configure anytime. For this case, what I'm doing here, I just use the default package, so there is no plugins being installed ahead of time, so I have to install manually on my own. All right, So that's the thing you can keep note here when you play with it. I encourage you to practice by create a custom Jenkins image to package things up. All right, let's jump to Jenkins. Once you confirm the Jenkins container is up and running, let's get access to the Jenkins UI. Here, I was still using the default port from Jenkins for port mapping, so which is 8080. So to get access to Jenkins, let's switch to my browser. You just need to type in localhost 8080 and type in your username and password. Then you should be able to get access to these homepage, right? So to be able to integrate with GitLab, we need to install some Jenkins plugins for GitLab, which does not come out of box. Let's go to the Manage Jenkins and Manage Plugins. So for my instance, I already installed those plugins ahead of time. On your end, if you're doing it the first time, just click Available and search for those GitLab related plugins by typing GitLab, the keyword. You're gonna show up, filter out other non-related plugins down here. So for me, I already installed, so I just click Installed. And then I'm gonna do some filter, like only show me plugins for GitLab. And here we go. Those were the 4 plugins that you need to install for GitLab integration. GitLab API plugin, GitLab authentication plugin, merge request builder, and GitLab plugin. All right. Just remember, recycle your Jenkins once the plugins were installed, right? And one thing to note, once you check that recycle button when you install the plugins, right? So you will notice when you refresh your browser, you won't be able to get access to Jenkins anymore because that container for Jenkins is going to be down. It's not able to restart automatically by itself. So if you to double check, just run that docker ps command again. At that time, these container for Jenkins gonna be gone. You won't be able to see these container anymore by these commands because it's down, right? You need to spin it up to be able to get access to the Jenkins UI again. So to do that, firstly, you need to issue this command, docker ps-a, to show you all the containers, right? Including the one that has been that is down, right? So and then copy and paste the ID of that Jenkins container and issue docker start. Paste that ID and hit enter. So your Jenkins container is going to be brought back up again, and then you should be able to get access to your console. All right, that's step 1. Step 2, you need to create personal access token on GitLab side. Let me show you how to do that. So here's my GitLab repository for this demo. And to create a access token, so you need to create your account button right here and click Preferences. And here in the left menu, just select Access Tokens. Here is the place where you create the access token. Just give a name and set expiration date and select the scope. Like you want to give the read wrap permission to the repositories and give the permission, and then click Create Personal Access Token button right here. So once you click this button, it's gonna show you the secret for that token. Just write it down and treat it as a secret because you don't want to share that. Here's mine. So I already created my token ahead of time. So once you create your token, you need to add that GitLab access token to Jenkins. For doing that, to store secrets secretly, you need to go back to your dashboard and click Manage Jenkins again. You want to store your access token here as the credential. Click Manage Credentials, and here is listed out the credentials that I created already. So as you can see, I already created token. I already created a credential to store my token right here. So for your case, you're gonna click Global Credentials and Add Credentials, right? So and then select GitLab API token, right? And copy and paste the API token right here. And if you want, give a description about it and click OK. And then back to my credential domain, you will see similar things like right here. This is my token. All right. Okay, so next step, I need to configure GitLab API settings on Jenkins. By the way, seems the GitLab API token that I generate ahead of time has already expired, so I had to generate a new token. So here I just created token named ZZTalk demo, right? So I need to update the credential on Jenkins side as well, which I did. And here to configure API settings, so we need to click Manage Jenkins and click Configure System. Give a little time, it's still loading. All right, so scroll all the way down to the section for GitLab connection and give a name. I'll call it GitLab public and give the host URL, which is gitlab.com, and credentials. So here I'm going to use the new credentials that I updated here, and just to verify, click test connection button, and here we go, it shows success. All right, and then click save to save this configuration, and all right, we're good to go. So the next step, and it's the last step, we need to configure to allow GitLab build commit push or pull authentication to GitLab. All right, so for doing that, we need to generate a public and private key pair on the container where Jenkins is hosted, and then we need to upload that key to Jenkins. So let me switch to my terminal, and here we go. So let me refresh my terminal and do a docker ps. What we need to do, we need to generate a public and private key pair on the container where Jenkins is hosted. So we need to log on to these Jenkins container by docker execute -it u as user. I'm gonna log in as root and copy and paste the container ID, and I'm gonna use bash. Here we go. I'm on that container now. So now where am at the slash directory. So to generate a key pair, we just need to issue ssh-keygen, hit enter, and it's gonna generate a RSE key pair. So by default, the key pair is gonna store it under this location. Again, already generate the key, so I just need to go to this directory and grab the key, right? On your case, you just hit enter all the way to set up some passcode if you want, and then hit all the way to hit enter, and then grab the key, like what I'm gonna do right here. So I'm gonna cancel it out and just go to root.ssh directory and do a ls, and here we go. As you can see, this is the key pair. That pub is the public key and this is the private key, right? So we need to, next step, we need to add the SSH key to GitLab, right? So for doing that, switch to your tab to GitLab, right? So click your account button right here and preferences, and on the left side, the menu bar, and in this case, you're gonna wanna click these SSH keys. All right, so as you can see, already created and upload the key here. So basically what you're gonna do on your end, you're gonna copy and paste the public key, which you just generate on the Jenkins server, to here, right? So just grab these public key, right? Just copy the whole thing here and copy and paste it right here, and give a name. Give a name of these SSH key, and you can set the expiration date, right? And click add key, so you will see your SSH key stored right here, right? That's step 2. So you just added the SSH key to GitLab, right? And then you need to add the SSH private key to Jenkins, right? So let's switch to Jenkins, and for add the private key, you need to go to again, manage Jenkins, and click manage credentials. And here, as you can see, I already uploaded the private key here. So for you, you can do basically the same thing. So click global credentials, add credentials. In this case, the kind will be SSH username with private key, right? And then you can enter the private key, enter in directly here. You just need to add that file. So click add and switch back to your terminal and grab the private key right here. Copy the contents inside this file and paste it right here. And if you, when you set up the generate the key pair, you set up any passphrase, you have to put the passphrase right here. For me, I did not set any passphrase, so I just leave these passphrase blank, as blank. All right. So once you add your private key and click OK, and you should be able to see something like this. So this is my private key. All right, so we uploaded public key to GitLab and private key to Jenkins. Now we're able to basically we basically allow GitLab View to commit to push or pull authentication to GitLab. All right, so that's pretty much it. So now let's switch to my repository, and I'll explain the pipeline. So it is a really easy one. I'm just gonna show you the Jenkins file, right? So here we go. Right, so this is a really simple pipeline right here. So there's only 2 stages. The first stage is to verify, K6 CLI is installed, right? So basically, the more detailed step is, firstly, I'm gonna run these, give the execute permission to these setup_k6.sh, this shell script I created right here, and then I'm gonna run these shell script to verify K6 CLI was installed on the Jenkins server. Click that. So it's a simple if condition right here. So it's just make sure run this K6 version command to make sure the CLI's command, if CLI K6 CLI is installed. If not, just follow the install instruction on the K6 official document. Do the install right here, right? So that's pretty much stage 1 for verification. And back to Jenkins file, and once K6 installed, next I'm gonna kick off or run run my scripts, right? So I'm gonna issue these shell commands K6 run, and I'm gonna export the results to the InfluxDB because I'm gonna store my data in these InfluxDB and present the data on Grafana, right? So here I'm gonna use these out arguments to point to the location of the table that I created in the Docker Compose file, this K6 table, right? And then the last piece is the scripts, which is under scripts folder, right? That's pretty much it. So once you created these Jenkins file, and you're ready to create the pipeline. So here, what you need to do, let's switch back to the Jenkins console and new item. So for this case, you're gonna build a pipeline. So just select pipeline and give a name of the pipeline. OC ZZ talk K6 Jenkins pipeline demo. All right, and click OK. All right, so here we're gonna so GitLab connection is GitLab public that we configured just now, right? And pipeline. So under pipeline, so for the pipeline, click pipeline. Pipeline definition, I'm gonna select this pipeline script from SCM. Right, the SCM gonna be Git, and the script path is gonna be the repository. So because remember the last step, we already configured the private public key on both GitLab and Jenkins sites. So we just need to so go to my repository. We just need to use this. Provide this click clone, use this clone with SSH. So we just need to copy these URL and then switch back to Jenkins. And here we just paste the URL right here. And credentials, we're gonna use the root, the credentials that we just created. So basically this is the private key we just loaded, right? So here, the branch specifier, we need to specify the branch as the default, which is main, right? And script path is going to be Jenkins file. So once it's configured, let's advance. There's something. Okay, that's pretty much it. So once it's configured, we just click apply and save. All right, so we got our first pipeline. So once we click build now, it's gonna the Jenkins is gonna download that repository from GitLab, and then it's gonna looking for that Jenkins file where we define the pipeline stages right here, right? And kick off accordingly. So let's do that by click build now. All right, and as you can see, the job is just kicked off. So let's click that and click console output to see what we got. All right, so as you can see here is verifying K6, and it passed the first stage, and then is moved to the second stage, which is running performance tests, right? So the test is kicking off, and let's give it some time to finish off the test. And because we already asked these pipeline to pipe the results to our backend, which is InfluxDB, so we should be able to see the results on Grafana, right? So all right, so the status code showing success. So we're all good. Now let's see. Basically, check here. The results is exactly what we got when we tested manually on my local, right? So this is the same results we saw from the my console, right? So let's switch to the Grafana. So let's do a refresh, and here we go. You see, all those results was fed to InfluxDB, and here the data source we already pre-configured to hook up with that table, and so we're able to see the result from here on the dashboard. All right, that's pretty much the whole everything I want to share with you. I think it gives you some idea what these new performance testing solutions is capable of. Maybe for your use case, just play with it and let me know what do you think. All right, thanks for watching, and I will see you next time.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.